So it's hour 2 of week 5, and we've set up our connection in Server Explorer, and now we're going to use this entity framework tool to generate the connection string and also generate model classes based on our 6 tables in our music store. So here's how we're going to do that. Over in Solution Explorer, I'm going to scroll down until I find my models. Now, last week we created this genre model. We're actually going to delete this because we want Entity Framework to generate a new genre model based on the table in our database. So I'm going to delete that file that we built last week. Let's get rid of it. And then I'm going to right-click on Models, and I'm going to choose Add New Item. So right-click your Models folder, choose Add, and then choose New Item. Now it defaults to the web template on the left with HTML files and Razor views and CSS. We don't want any of these. We want to choose from up above, click Data. So just 2 options up from web. Beneath code in general, there's data. And the first option here says ADO.NET Entity Data Model. So I'm going to select that one. And I'm going to call it Music Store Model. No spaces, and the first letter of each word is capitalized. We don't need to give it the .cs extension. Visual Studio will assign that automatically. So we added a new item, we picked data, and we want an ADO.NET Entity Data Model called Music Store Model, and then click the Add button, the bottom right. And this will bring up another little dialog box. So it says, okay, there's 4 different types of data models. The first 2 are kind of old. We don't really use them. Typically, we use one of these, an empty code first model, meaning we're going to we already written the classes, and we're going to use it to build the database. We want this last option, code first from database. We already have a database with tables. We want Visual Studio to write the classes based on those tables. So pick that one, code first from database, and just click next. Now it already finds the connection that we set up in Server Explorer. And then it asks, include the credentials in the connection string. We'll pick yes. And then this box should be checked off by default. We want it to be checked. Save connection settings in web.config. Remember, we deleted the connection that was there, so we're going to replace it. We're just going to change the name. Instead of calling our connection string Music Store Model, we're going to use the same name it was already there, which is default connection. And this name is kind of this is sort of a keyword. The reason we're going to call it default connection is because in a few weeks when we add authentication and security, the library we use looks for a connection string called default connection. So if we already have that set up for today, it will already work when we go to integrate some of the authentication libraries. So just pick yes, check that box, leave it checked and call it default connection and click next. So now the wizard says, okay, we're connecting to that music store database. Which objects do you want to include in our model? Now our database is fairly simple. There's only 6 tables, so we're going to include all of them. Database with hundreds of tables, we may not want one single model. We might make different models for different parts of the application. We put related tables in each model. Here we can just click tables. And then it automatically selects all 6 of the tables. We want all of them in our model. But if you just click tables at the top, views you can leave. We don't actually have any views. So just select the tables. We can leave this box checked that says pluralize or singularize object names, and then just click finish. And then we can see, so we started out with 3 models here. in Wizard is going to generate 6 new models in here. And each one will be mapped to the corresponding table in our SQL Server database. So obviously, the more tables we add, the longer this process takes. And then we'll get this message. It says your web.config file has been changed because Visual Studio has added the database connection string. So it says, do you want to reload it? We'll say yes. So it opened up this references because it added a bunch of libraries we need. I'll just close that up. Notice now inside of models, we now, rather than 3 files, we now have 9. Because we got the 6 models generated. So now if I open my genre.cs, so this has been auto-generated. So it says the table that this is modeled on is the genre table. It shows the relationship, the one-to-many between genres and albums. One genre has many albums. And then it's got properties with all the right data types. It even has things like validation rules. So in our database, the name only allows 120 characters. So it sets out that that's the maximum here. And for this field, for the description, it's 4,000. And in my web.config, you can notice on line 13, it now rewrote our connection string. So now our application can connect to our MVC Music Store database. That means you didn't already delete the old one or you didn't save the change. So you'll need to cancel the process. Go into web.config and delete the default connection and then redo the process, Alex. That'll fix it. So it's got my full connection. So we don't have to write the connection string. Remember in our PHP class, I made you type this stuff over and over again until you learn how to do it. We really never need to do it. We'll just let Visual Studio write it once. It's in web.config, so now our entire site has access to that database connection. So we have models generated for all 6 of our tables in the database. So I'm going to build my solution. So the first thing we want to do is with just a couple lines of code, we want to change this page so it no longer says genre 1 to 10, but it shows the real genres from the database. We're connected to the database now, so we should be able to pull information from SQL Server and display it here. Okay, so we're going to want to change this store index. So the models, typically we don't have to change a lot. Today we're not going to touch them. We're going to use them exactly the way they were auto-generated. Next week we'll look at making a few changes to them, but we don't need to change anything today. So now I want to go into controllers and open up the store controller that we built a few weeks ago. So last week on our index method, we created kind of this pretend list. With the loop, we generated 10 imaginary genre records, and we passed this to the view. So we don't need this, so I'm going to highlight and I'm going to comment out all this code. Now, you can delete it. I'm going to leave it in the easiest way. There's a little toolbar here for commenting and uncommenting. So you can just highlight a block of code and click comment or uncomment. By default, you probably don't see this little toolbar here. I'll show you how to turn it on if you want it. If you click on the View menu and Toolbars, if you enable this text editor, that will give you the little comment and uncomment buttons. So I'm just going to put in a comment here. So this was in week 4. So now I'm going to grab that code and click comment out, which now gives us an error because we're trying to hand the list of genres back to the view, but we no longer have any code that fills the list of genres. So rather than mocking up 10 pretend records, we're going to use our model. So running a query with our database is as simple as this. Again, we'll recreate our genres variable. Yeah, whoops. We need to do one thing first. Sorry, we'll come back to that. We now need a line that connects to the database in here. Before we can run a query, we need a database connection. So our connection string lives here. And actually, I misspoke. I said we got 6 new classes here, 6 new models. We actually got 7. Remember, we named our model the music store model. This is the class that does all the work of connecting to our database. And it says it uses, so the type of class is DB context. That's a database connection class. And it uses the default connection in our web.config. So up here above my get, we're going to connect to the database. So anytime we use our store controller, it automatically connects to the database before it runs any method. So I'll create a variable called DB, and it's of type music store model. So I set it equal to a new music store model that connects to the database. Nice and simple. So then we can use this DB variable to run a query with any of our models. I could put it inside my index method, but I want to put it above, meaning any method in this controller has an open database connection it can use. So now we're going to use our database variable to run a query. So I've added line 13. This is new. So we'll create a genres variable, and to run a query, it's this simple. DB, that's our connection, dot, and now it brings up all the models, all the individual models in the music store model. So db.genres dot to list. That will run a query and get all of the genres from the genre table. And our code here that hands that data to the view, that stays the same. We don't have to make any changes. So we added line 13. We commented out everything we had before in index, and we added line, so 13 and 31 are new. And now if we build and click our store link again, it should now show us the real data from our database instead of the pretend data we made last week. So now if I reload my store, so we've changed the data source from a list in memory to actually talking to our database. Notice we didn't have to change anything in the view because the view just displays whatever is handed to it in an object called genres. So we had to change nothing in the presentation layer to get our page to work. So this is new, and this is new. So we didn't have to write an SQL command. We didn't have to write any kind of complicated connection. So now we can click one of these and it takes us to our browse page here. So our view, our store index view, it's the same. It's still expecting a list of genre objects, and it just loops through the genres and prints out those list items in a loop. So we don't have to change anything here. We're just changing the data source on the back end. So we're going to want to change this method as well. When the user clicks on one of these, we do want to display the title at the top, but what information should we show the user? If they click on one of the styles of music, what do they want to see? Yeah, we should show all of the albums in the albums table that are linked to the genre they selected. So just like we used our genre model here to run a query, we're going to do a similar thing, except instead of selecting a list, we want to select one genre, whichever one the user clicked on, and then we want to include all of the child data, so all of the albums that are related. So let's modify our browse here. We've already got a connection we can use here. We can't use the name genre because that's already used here as a parameter. That's the name that came in. So we'll just use G to represent the selected genre. So we want to get the selected genre. We already know the name, but we want all of the albums that are connected to it because there's a one-to-many relationship. One genre has many albums. One album belongs to one and only one genre. So we have this include function. So get the selected genre, but include all of the related albums. And single or default, that's when we want to query and look up one record. And now we need to create some kind of a where clause to explain which one we want. So I've got to create one other little alias for the genre. So whatever name, whatever the user clicked on, that's our where clause. So where the genre name is equal to that value, that gives us that one record. So this gives us that one record and all the related child data. We now need to hand this little G variable back to the view. So how would we hand the view that data? Yeah, in the return, when we're returning the view, so G is the result of our database query, we want to give that query result to the view, because then we can display all that information. So we probably don't even really need to use the view bag anymore. So I'll change the comment and say, get the selected genre from the DB and include the related albums. So we don't have to write a join statement to get parent-child data. We can just select the parent record and use include to reference the child data. So we have two methods. We have single or default. Using the or default, that's just in case the genre is not found. It won't give us an error. That's just a bit of error handling. So now we want to open up our browse, because right now it prints out the name at the top, but that's all. We want to also build a table that shows all of the albums that are here. So let's go to Store Browse. So just like we did on our index, we need to declare a model. We need to tell the view what kind of object, what kind of data are we giving it. So on this page, we got a list of genres. On this page, we're also getting a genre, but we're only getting one record, not a list. Like we used here on the index view. We probably don't need to use the view bag at all. So I'm going to go back to my store controller. I'm going to take that line out. Rather than using the view bag, we're handing back the genre object that will include the name. So instead of viewbag.genre, this can be model.name. And now let's create a table that displays all of the related albums. So I'll use a few of the Bootstrap classes for formatting. Can have a look for a minute. We're going to display the albums. So if I open up album, we can see the names of the properties, and we can decide which properties we should show in that table. A genre ID, an artist ID, a title and a price, and the cover image. So maybe we'll include the title of the album. We don't want the artist ID. What should we show instead of the artist ID that would be meaningful to our user? Yeah, probably the artist name and maybe the price. So we'll create 3 headings. First one can say title. Whoops. So we'll have a heading for title, heading for artist, and a heading for price. So we've gotten rid of the view bag. If we refresh the page now, it should still show the name at the top, and we should see a heading, no data in the table, but we should see one row with those 3 column headings that say title, artist, price. So if I go back, I need to rebuild because we made changes to the controller. I didn't build. So I'll build my solution. So we've got our table. Now we just need to use a loop to populate our table to display any albums belonging to whatever genre the user picks. So here we can use if for each. So what we want to do is loop through. Notice our model has an albums property. So we want to loop through the albums. And we put on a set of curly braces. So this is what happens inside the loop. We'll create a TR. With 3 columns. And now we can just use our G variable. Actually, I guess this should say A, more descriptive. A for album. So first column, we're going to display A.title. Second column's a bit different. We can't just display artist because artist is its own object with a whole bunch of properties. We want the artist dot name. And then we want A dot price. So we don't need to rebuild, we don't need to build again. We should just be able to refresh. Choose any genre, click on it, and this page should now bring up a list of all the albums in that genre. I'm just going to test mine and make sure it's accurate. So I pick pop, I get 2 albums. I get a lot more here. So notice how clean our code is. It's presentation only. There's no logic here. We're not talking to the database. We're not running a query. All this page does is present the data that the controller and model work together to get.
So on the store index page, would there be a way to arrange the genres alphabetically? That's
a great idea. We should probably arrange both of these alphabetically, because even this is not a very good list, right? This is sorted. It's actually not sorted at all. This is just by album ID, which if it's a long list is not very helpful to users. That's a good point. There's a few changes we should make. Sorry?
Bootstrap table has that built-in.
Sorting?
Yeah. I know you don't want to do that.
Okay, well, you know what? We'll do it next week. We can add, there's also a JavaScript library we can just import that will do it. But it won't do it, but we also initially should get it the initial query. We should also format this as currency. So we can add something here around the price. To format it as currency, we can use a string format. We say string.format, and in curly braces and quotes, this is a Microsoft shorthand for a currency format, 0:C. This D stands for currency. If we want to do dates, there's different date formats. A lowercase d would be a short date, like month, day, year. It would hide the time, for example. So if we try that and refresh, this should get formatted with a $sign now, which it does. So Ryan, I like your suggestion. We should probably sort, both of these lists alphabetically. Would make a lot more sense, be much more useful to our end user. So if we go back to our store controller, We can try it right here, actually. I'm not sure if it'll work here, but after we call toList, I think if I put in a dot, we have an order by, which I think would look like this. I think if we sort by the name on index, we'll try this out. We'll refresh our index and see if that sorts our bulleted list of genres alphabetically from A to Z. So I've added this to it. We'll have to try it. If not, there's another way we can do it. Let's see if that did the trick. Yep, that seems to work. So after we call toList, we can add an order by on there. So we could actually do the same thing here. Actually, maybe a little more complicated here. Let's see if we can do it here. Dot. Let me think about it for a minute. I think we may have to make a separate list. I can't do the order by here, I don't think. Oh, maybe. Hang on. A little more complicated because we want to order. We'll see if that works. I'm going to try it. I'm not optimistic that will work. We'll see. Yeah, it doesn't like that. Okay, I'll have to think that one through. I'll leave that out for the moment. We'll look at allowing the user to sort it on the front end next week. So they can click on any column and sort by that column. So this one's simpler because it's simply one list. Here we want to sort by the child data. That's the complication. I'm going to leave that out for now. Actually, hold on. Let me think about it. Would include. So let me try it this way. I'm going to give it one other try. I think we can do order by. Oh, then by. No. Okay. I'll leave it for now. Okay, are we for time? Oh, we're good. Okay, think what I want to do. I'm going to push what I've done so far up to GitHub. I also want to, one thing we haven't done with our Git repository so far, if I go to it, one thing that I've left out so far, which is not a good idea, when we create a repository, we probably should create a README file. What is the README file? What is the purpose of it in a Git repository? It's going to be one of the things I'm going to ask you to do in your assignment, is create a README file on your repository. Why?
Display message.
Okay, but what? Yes, could be a little more specific. What, like, what's the purpose? What kind of messages would we put in the README file? Josh?
Maybe like the purpose of what this is, and like just like maybe how to use it or set it up.
Yeah, so any instructions and an explanation of what our project is all about. So for example, here's another example. So I did this in my Thursday class. We made the README file. So here's my Thursday music store. So when you load the repository, the README shows, and whatever content's there, I'm explaining what the application is, what tools we've used, and I've given a link to my live website. So here's a student in one of my other sections. So here's his first assignment. With the README, it explains how his application works. And again, he's given me a link. So whenever we create a repository, it's a good idea to put a README in, especially if you're going for a job interview and the employer says, I want to see your GitHub, that they're not just clicking the repositories, but each one has a README that explains what the project is and what it's all about. You know, this is a JavaScript project, this is CSS, this is ASP.NET. So they know what those repositories are and they can look at the ones they're interested in. So I'm actually going to create a README file and put my code up on GitHub. Then we'll take a break, and then when we come back, we'll do one more thing today. So in my solution right here, I'm going to choose my solution. I'm going to right click and choose add a new item. Now, I don't think README shows up in this list, which is okay. I'll just pick text file, and I'm going to call it readme.md. So this is the name GitHub expects, and then it will automatically show this page whenever someone comes to our repository. So MD stands for Markdown, so we can write regular HTML in here, even though it doesn't have an HTML extension. That's okay. So add a new item right in the root of your solution called readme.md. And we can just write a little basic HTML. So I'll just put on a heading. And I'll just put on a little description of what this application is, as well as include a link to my site on Azure. You can say whatever you want here. So I'm just going to go to my Azure portal and grab my link. Actually, maybe I've got it here somewhere. No, I don't think I do. So I'll go to the log into the Azure portal and grab the link. Again, this is helpful if someone wants to actually not only look at my code, but then they want to actually see the live site. So, okay, well, this is what you've been doing in class. Cool, I want to see the actual project. So I'll just copy the URL from the Azure panel. So that's a simple enough README. So now I'm going to commit everything I've done to GitHub, but it will include the README. So when you go to my repository, you'll now see this on the main page of the repository. So I'm just going to open up my command window. I'll go into my music store folder and copy that address. My little command line extension doesn't seem to be working for me, so I'm going to go in this way. If you have the little command line tool installed, you can just open the command line right from within Visual Studio. Just right-click your solution, and you should have open command line down here. So I'm going to add all my files from today so far with git add dot. End of week 5, hour 2, DB connection, and README. So that's what we've done so far. You can put in any commit message you like, doesn't matter. If I push, it'll put my changes on GitHub, including the README. So I'll push from my origin to the master branch. So here's my repository so far. If I open it in a new window, now that I've committed and added the README. So now the README shows up here. And I have a link to my live site as well. So in your assignment, which I will give you before we leave today, one of the requirements is to include a README file in your GitHub repository. And I'll go over the things that should be in the README. This is some of it, a description of the application, but you'll need some other things as well in there. And we'll talk about that next hour. Okay, so all the code we've done so far today is on GitHub now, along with this documentation file. Are there any questions before we take a break? Okay, then I'll stop my video and we'll come back at 4 o'clock. We're going to do one other thing using our database. We're going to add a bunch of other add another controller and a bunch of views to our application. It's going to be really easy to do. We don't have to write any code at all. That's how easy it will be. And then I'll give you your assignment. Okay, we'll come back at 4 o'clock.